Hello all, welcome to this class on projection of solids, and in this class let's try to learn a problem on hexagonal pyramid. And the problem is a hexagonal pyramid 25 mm sides of base and 50 mm axis length rests on HP and one of its slant triangular faces. Draw the projections of the pyramid when the axis is inclined to VP at 45 degrees. So in this problem let's try to, the only difference between last problem and this problem is in the last problem it was mentioned as the pyramid was resting on one of its slant triangular edges. So slant triangular edges in the sense you can try to it's nothing but a corner condition problem. So you can we just saw the pyramid was the prism the hexagonal pyramid, the base of the hexagonal pyramid was placed in the corner condition whenever it was mentioned as slant triangular edges. So in slant triangular faces, the only thing what we are going to do it is we are going to place it in edge condition. So for that, first let's try to draw the XY line, that is the reference line, and then what you will be doing it is switch on the caps. So name it as X, Y, VP, HP. So VP, HP, and then what you will be doing is go to line, go to visible line, just draw a line first, just draw a line, and then use your keyboard. So length tab 0 enter, that's what is the first thing what you're going to do. So the length that is given is 25, tab 0 enter, 25 tab 60 enter, 25 tab 120 enter, 25 tab 180 enter, 25 tab 240 enter, 25 tab 300 enter. So that is what we are going to do here. Now we'll have to place this hexagon in the edge condition. So to place it in the edge condition, one edge has to be perpendicular to this reference line. So one edge on the extreme right side has to be an edge. So let's try to rotate that. Go to rotate. See that the copy is switched on. So let's try to use this edge, this bottom or the top edge, because that is at present it's parallel to this XY line. So let's try to make it perpendicular. So if you have to make it perpendicular, let the rotation angle here you can make it 90 degrees. So 90 enter. So let's try to place it there. So now let's try to move it a little bit closer to this XY line. See that so from when you're moving you can select it and you can pick it from anywhere. So now let's place it here. So the immediate thing what you'll be doing after that is go to using the visible line itself, just draw lines such that it joins every corner. See that it's joining every corner. So immediately what you're going to do it is, so go to text option and let's try to name it. So let's try to name this A, B, C, D, E and F. E and F, and let the midpoint, that is, let that be named O, and within the brackets 1. So now so O and within the brackets O1. So now let's try to draw the projections using normal lines. Using normal line, draw projections till this XY line. So till the reference line first, let's draw that. The next thing what you'll be doing is, see that the axis length that is given is 50. So go to center line. So give from there give 50 enter. It is 50. Go to visible line and join that to the apex. So join it to here. So now we have just joined it. So next thing is name that as well. So let's do the naming here. So when the observer sees from here, this points A, B, C all will be visible while D, E, F will be hidden. So in A and F, A will be visible while F will be hidden. So let's try to draw it as A dash and within the brackets F dash. And in this let's try to draw B dash and within the brackets E dash, and also you will have to mention O1 dash here within the brackets. So let's try to mention that as well. So open the brackets and mention O1 dash, because O1 dash will also be hidden. And here's C dash and D dash. So C dash will be visible while D dash is within the brackets. And here let's try to mention O dash. So now that completes the first stage of this problem, but using this zoom area option, see that you are trying to use zoom area option and trying to move it to a particular position. So to an appropriate position, let's try to name it. Okay, now that completes the first stage of the problem. So in the second stage of the problem, they are mentioning it clearly, that is the pyramid. You can just see in the question, it is clearly mentioned as the pyramid is resting on HP on one of its slant triangular faces. So on slant triangular faces, in the sense, so let's try to select the same edge and let's try to rotate it just like how we did in the last problem. So let's try to select it using this control key in the keyboard. So after selecting it, click on the move option, and just at this corner let's try to pick it and just place it over here. Now let's try to rotate that. Let's try to rotate it on one of its slant triangular faces. So this is the slant triangular faces, or the slant edges, however you can say. So let's try to let's try to select one corner, and let's try to select the other corner, and let's exactly place it over here like this. So that's it. And what you can do it is using move option again. Let's try to see that the copy is switched off. So let's pick somewhere and try to move it closer to this, so that you'll get enough space in the third stage. Next thing what you can do it is just move those points, see that the copy is switched on. So this is E dash, EF dash, well this is B dash, E dash, well this is C dash, D dash, well this is O1 dash, well this is O dash. So see that now you try to draw the projections. So let's try to draw the projections using normal lines. So O dash to O, while let's try to draw from O1 dash to O1. So see that it's straight lines. So suppose if it is not straight lines, try to delete the projection and redraw it again. So you can just zoom it and try to draw the projections. If you're not getting a straight line, you can enter 90 degrees so that you will get a straight line. So from A dash to A. So see that the alignment indicator is kept on so that it will be easier for you to draw the projections. So A dash to B. While this is the same as for B dash, E dash and O dash. So from B dash, let's try to draw a projection. Let's try to zoom it and see whether if it is drawn correctly. Yes, it is fine. So let's try to zoom it again here. So let's try to draw a horizontal projector from B, and let's try to extend it like that. And now using this extend to next option, you can just extend this so that from B and E there is already a projector. So from E you can extend it till here, and from C So from C it is here. So from C a projector is drawn. Similarly from D another projector is drawn here. So from A a projector is drawn. From B another projector is drawn till here. Similarly from C a projector is drawn till here. So it extends till D, and from E is still here. From F it's still here. So let's try to trim these lines. Now let's try to name these points, and if possible let's try to move it. So see that you can try to move it. So here let's try to move these points. So A dash to A is here, so let's try to move, and this is A, and from B it's here. Let's try to move that option B, and from C an option a point is here. Let's try to name that C, and from D a point is here, a projector is here, therefore this is D, and from E there is a projector here, therefore this point is E, and from F there is a projector over here, and that point is F, and from O1 dash the projector is here, therefore that point will be O1, and this point will be O. So now using move option, let's try to place everything correctly. So this almost looks fine, so let's try to place this here. So see that the copy is switched off again. So when the observer sees from here, that is when he sees from here, this point will actually be visible, C dash and D dash. So C dash and D dash will actually be a visible line. So from there C dash to D dash to O dash, so C to D and O to C to D and C to O, that will also be the visible line. So that is when the observer sees from here, C to O and D to O, so that will be made visible. So let's try to draw a visible line from C to O and from D to O as well. So the next thing what you will have to do it is draw the outermost points. So let the outermost boundary lines be made visible here. So let's try to zoom this. So from O to E is an outermost boundary line, from E to F is a boundary, and from F to A is a boundary, and from A to B is a boundary, and from B to C is a boundary. So all these are the boundary lines. So all these are being made boundary lines. And now the endmost point. So you can just see the endmost point is O. So the lines that is coming from O to A and O to F. So O to A and O to F is actually will be made hidden. So O to A. So go to hidden line and select the thickness to be 0.5. So O to A and O to F. Just see which are the other points to be drawn. So as I told, from here when the observer sees from here C to O and C D to O, that one is already been made visible. Then from C to O1, instead of saying C to O, let's say even C to B and D to E. And D to E, that will also be made visible. So C to B, D to E. So C to B is already visible. Well, D to E will also be made visible. Then you can ask me C. So C to D. So C, O to C and D to C. I mean O to C and O to D is being made visible. But even C to D, that will also be made visible here. C to D. So apart from that, Actually, D to E is not a hidden line, it's a visible line. So I have just made it. So let's try to make that visible line. So apart from that, even D to C is a visible line. So as I told, only these two, there is O to, as this is the inmost point, O to A and O to F. That one will be made hidden. So apart from that, all other things will not be hidden. Only O to A and O to F will be made hidden. And next one is this O to O1. That one has to be made a center line. So go to trim and try to make that. Go to center line. So now I think the entire problem, and here I think I have just made a mistake here. This is not the boundary line. So the boundary line is this one. So let's try to delete that. That is not the boundary line, as I told. So this one is the boundary line. So here, okay, I mean this one, okay, that's right. And here I have just forgot to draw a boundary line here. So now that completes the second stage of the problem. So I think almost everything is done. Okay, now let's try to zoom out. So now if you just look at into this problem, so let's try to go into the third stage. So in third stage, that's when the axis is inclined. The axis O1 has to be inclined at 45 degrees. So now let's try to measure this axis first, the axis length. So this is the axis. So if you try to measure that axis length, so it is found to be somewhere around 45.88. So initially it was 50. So you can just see here, initially it was found to be 50. So 50 to 45.88. So that means the axis length has reduced. So whenever there is axis length has reduced, that means it is the apparent length. So whenever there is an apparent length, obviously there will be an apparent angle as well. So here you will have to find out that apparent angle. That is very, very important. So you can't directly take this 45 degrees, but initially you can mark it 45 degrees. So let's try to do the third stage. So first let's try to mark it 45 degrees. So first let's try to mark it 45 degrees here. And once you do it, you can then let's try to find out. So go to angle between and try to find out this angle, and that is, so let's try to make it 45 degrees. So the next thing what you'll have to do it is, you can just see initially the axis length is 50 and later it is 45.88. So go to arc by center point. So arc by center point. So let's try to draw an arc. Let's try to take the radius as 50. So let's try to draw a line such that it is passing on to this. So now let's try to draw another arc here. Arc by center point. Let's try to use the same arc. And such that this time let's try to give the axis the radius length as 45.88. See that it's trying to cut this line. So wherever it is cutting that line, join a line over there. Now if you try to measure that angle, so let's try to measure that angle. Okay, I mean let's try to do that again. So it looks slightly, there is some mistake over here. So let's try to do that again. So initially how much do we took it was, initially we took it for 45 degrees. Yes, this is 45 degrees, that's fine. And initially this was found to be 50. So the next thing what we will be doing is, so the radius we took it 50. So first draw a line over here. So let's try to zoom it and try to draw it so that you will get it correctly. So try to zoom it. So just try to draw a line. That's fine. So let's try to zoom it and see. So I think when you zoom it out and see, you'll get it better. So let's try to draw a line correctly over here. So now it looks fine. So just try to draw a line over here. So now just zoom that part and see that now you try to go to this arc by center point and placing the center here. See that you're trying to cut an arc. So such that give the radius as 45.88, that apparent distance. See that wherever you're cutting an arc, so within that line, so within that intersection, point of intersection, a line has to, so you're just joining a line. So now if you try to measure the angle between that, so it is found to be 50 degrees. So initially when you found out it was found to be 45 degrees. So initially the angle was 45 degrees and now later you can just see that is 50 degrees. So wherever that arc is cutting this line, so just draw a line within that. So that is found to be 50 degrees. So now onto this 50 degrees line, we will have to place that axis. So that is very, very important. So upon this 50 degrees line only, we'll have to place it. So let's try to delete these arcs, all these arcs, everything. So all these arcs and all these extra lines. So let's try to place that pyramid onto this 50-degree line. So that is very important. So let's try to select that. So once you select, before you try to select that, see that you're trying to select every point. So once you just, simply select it, not all the points will get selected. As I told, the center point, you need it very well. So let's try to use the split option and try to, so that even that will get selected. If you just try to select this entire projection gets selected. See that you split it. You try to use that split option and split at these two ends. So go to split. Okay, let's try to use the split option. So and try to split it over here. So now if you try to select that, only this line particularly gets selected. So now using this control key, let's try to select these lines. So now we have selected all those points. See that the copy is switched on, and let's try to move it and see that you're trying to zoom only this particular part, and let's try to move it using okay, it just didn't get selected again. So let's try to select it again. So now I have placed that corner onto this 50-degree line. So now using rotate option, so let's try to select this. So let's try to pick on one corner and the other corner. See that the copy is switched off now. Let's try to place that corner onto this 50-degree line. So it is placed on this 50-degree line now. So this is found to be 50 degrees. So it is placed on this 50-degree line. So that's fine. So now let's try to name it. So let's try to move those points, all that. So let's try to move those points. So B, C. So let's place this, let's name this as A and this as F. This is E. This is D and O. So now all the points have been moved. So even move this O1 as well. So now we have moved all those points. So now let's try to draw the projection. So that is very, very important. So let's try to draw those projections. So to draw those projections, let's try to zoom this particular part. So let's try to use a normal line and let's try to draw the projections. O2, O dash, A to A dash, B to B dash, C to C dash, D is here, D to D dash, E is here, E to E dash is here, and similarly F is here, F to F dash is here, and O1 is here, O1 to O1 dash is here. So now let's try to move those points. So O is here and O dash, so this one will be O dash, and let's try to name the other points. And O1 is here, therefore this one will be O1 dash. Now let's try to name the other points. So this is A dash, while this is B dash, while this is C dash, while this is D dash, while this is E dash, while this is F dash. So now let's try to move those points and place it correctly. So let this be O dash. So let this be B dash, let this be C dash, let this be D dash, O1 dash, E dash, F dash, and E dash. So this is A dash, B dash, C dash, D dash, E dash, and F dash. So O dash and O1 dash. So when the observer sees from here, all these 6 corners A, B, C, D, E, and F, that will be visible. So the first thing what you can do it is join all those 6 points using the visible line. So A dash to B dash, C dash, D dash, E dash, and F dash. So the next thing what you will have to do it is join the boundaries. So the boundaries will have to be joined using visible lines. So from O dash to O C dash, similarly O dash to B dash and O dash to E dash, that will be joined using a visible line. So the next thing is check for the endmost point. So the endmost point is O. So therefore from the lines that is coming from O to E and O to D. So O to E, D and C. So O to E, D and C will be made hidden, while O to B, that will be visible. So O to B can't be made hidden. So O to E, D and C. So O to E, so it's not even C. I really don't think even C can be made hidden. It's only from O to E and O to D, because that is the endmost point. So O to E and O to D, that one has to be made hidden. So O to E and O to D. So let's try to join that using a hidden line, O to E and O to D. So go to hidden line. So give it 0.5 O to E and O to D. That one will actually be joined using a hidden line. So apart from that, I think all the other things are done. Now go to here center line and join O to O1 using center line. So I think that completes the problem. So I think all the points have been joined now. So I think that ends the problem. So hello all, welcome to this class on projection of